Students, today we will start exercise 1.2. In this exercise, we are going to prove irrational numbers. Question number 1, prove that root 5 is irrational. From today, we will mix language, English as well as Marathi to some extent. Everyone knows root 5 is irrational, but today we will prove that why root 5 is irrational. Root 5 irrational आहे. Why it is irrational, that is to be proved. Here we will prove this by indirect proof. First is, so answer, first step is, let us assume that root 5 is rational. Root 5 irrational हे प्रूव्ह करायचे. For some time we assume that root 5 is rational, and as per our assumption we can apply the definition of rational number, that is any rational number can be expressed in terms of a upon b, where a and b are integers and b not equals to 0. And one more thing here we need to write is a comma b are co-primes. See, therefore we can write root 5 is equals to a upon b. Why? Because we have assumed that root 5 is rational. As it is rational, we can write root 5 is equals to a upon b, where a comma b are integers, b not equals to 0, and also a comma b are co-primes. This is very important. Co-prime numbers. Now everybody knows what is co-prime number. Even then we will revise it. The numbers which have no common factors between them, those numbers are called co-prime numbers. For example, let us take 14. Factors of 14, 2 into 7, and factors of 15, 3 into 5. See, 14 is a composite number, 15 is a composite number, but the factors of 14 and 15 does not contain any common factor. That's why 14 and 15 are co-primes. So a and b are co-primes. That means a and b have no common factors. Okay. Now next step, transfer b here, so it will be root 5 into b is equals to a. We can write root 5b only, into 9 लिहिले तरी चालेल. Root 5b is equals to a. Squaring both sides, square of root 5 is 5, b square is equals to a square. Now look at this step, 5 into b square, that means 5b square is divisible by 5. As 5b square is divisible by 5, a square has to be divisible by 5, because there is equals to sign between 5b square and a square. Therefore 5b square is divisible by 5. Therefore a square is divisible by 5. See, as LHS is divisible by 5, then RHS has to be divisible by 5, because there is equals to sign between LHS and RHS. Now as a square is divisible by 5, a is also divisible by 5. Therefore a is divisible by 5. Let us write it as a statement number 1. a हा 5 ने डिव्हिजिबल आहे हे सांगून ठेवलं आपण. नाउ as a is divisible by 5, see a is divisible by 5, we can write a is equals to 5 into any integer. Let that integer be c. That means a can be written as 5c, where c is any integer. So therefore a can be written as 5 into c, where किंवा for any integer c. Now the value of a is 5c. We will put this value here. 5b square is equals to a square. We will substitute a by 5c here. Therefore 5b square is equals to a means now 5c, that is 5c bracket square. So 5b square is equals to square करायचा 5 चा square 25c square divided by 5 on both sides, dividing by 5 it will be b square is equals to 5 कट होणार आणि 5 5 is 25 5c square. Now look at this last step. We have arrived at b square is equals to 5c square. That means 5c square, which is RHS, is divisible by 5, because 5 into c square, that means 5c square is divisible by 5, and as 5c square is divisible by 5, b square is also divisible by 5. बघा RHS आणि LHS कडे दोन्ही बाजूंना 5 ने डिवाइड होणार, कारण RHS ला 5 ने डिवाइड करू शकतो आपण. 5c square आहे RHS ला. So 5c square is divisible by 5. Therefore b square is also divisible by 5. And then we can write b is also divisible by 5. Here we can write 5c square is divisible by 5. That means LHS b square is also divisible by 5, and b square divisible आहे म्हणजे b is also divisible by 5. Therefore b is divisible by 5. Let it be statement number 2. See, it is very important proof. I will repeat it 2 times after we finish. b is divisible by 5. Statement number 1 says that a is divisible by 5. 2 नंबरचं स्टेटमेंट सांगतं b is also divisible by 5. That means 5 is a factor of a and b also. 5 हा a आणि b चा पण a चा पण फॅक्टर आहे आणि b चा पण फॅक्टर आहे, म्हणजे a आणि b मध्ये हे 5 हा कॉमन फॅक्टर झाला. म्हणजे आपण हे जे लिहिलेलं आहे a आणि b को प्राइम असणं हे रॉंग झालं, कारण आपण इथं सांगतोय की जर तो रॅशनल असेल तर a आणि b काय असले पाहिजेत, को प्राइम असले पाहिजेत. परंतु ॲज पर आवर अझम्पशन वी हॅव अराइव्ड for 2 steps, that is a is divisible by 5 and b is also divisible by 5. That means 5 is a common factor for a and b both. That means a and b are not co-primes. So this is a contradiction, and this contradiction is due to our assumption. आणि मग जर कॉन्ट्रडिक्शन आलेला आहे आपल्या ॲझम्पशन मुळे, तर याचा अर्थ आपला ॲझम्पशन रॉंग आहे. दॅट मीन्स आवर ॲझम्पशन इज रॉंग. अँड व्हॉट इज आवर ॲझम्पशन? √5 इज रॅशनल. अँड as it is wrong, we can say that √5 is irrational. This is how we can prove the proof, or we can prove √5 is irrational. So here we have to write from statement number 1 and statement number 2. I can write, or we can write, 5 is a common factor for A and B. Therefore, A comma B are not co-primes. Therefore, किंवा this is म्हणूया, this is, this contradiction is due to our assumption. Therefore, our assumption is wrong. Therefore, we can say finally √5. What is our assumption? √5 is rational, but which is wrong. So √5 is irrational. Hence proved. Again we will revise all steps. See, any number √5, √3, √7, √2, out of √2, √3, √5 and √7, any number can be asked. In this year, March 2026, √3 is asked. Prove that √3 is irrational for 3 marks. 90% क्वेश्चन पेपर मध्ये तुम्हाला हा क्वेश्चन दिसेल, either √3 or √5 or √2 or maybe sometimes √7. So first step is, let us assume that √5 is rational. We need to prove it is irrational, but let us assume that √5 is rational. As √5 is rational, we can apply the definition, we can apply the property √5 is equals to A upon B, where A and B are integers. Denominator B should not be 0 and A comma B has to be co-primes. That means A and B does not have, should not have any common factor. Now transfer B here. √5 into B is equals to A. Squaring both sides, 5B square is equals to A square. As there is 5 into B square on the LHS, that means 5B square is divisible by 5. As LHS is divisible by 5, RHS has to be divisible by 5. Therefore, A square is divisible by 5. Therefore, A is divisible by 5. As A is divisible by 5, we can write A is equals to 5 into any integer, that is 5C, for any integer C. Now, substitute A by 5C here. We can write 5B square is equals to 5C bracket square. That means 5B square is equals to 25C square. Dividing by 5 we will get B square is equals to 5 square, 5C square. Here also इथं सुद्धा आपल्याला असं दिसतं की RHS ला 5C square आहे. That means 5C square is divisible by 5. And as 5C square is divisible by 5, B square is also divisible by 5, and B square divisible ahe, the B is also divisible by 5. So statement number 2, from statement number 1 and 2 we can write 5 is a common factor for A and B. That means A and B are not co-primes. This contradiction is due to our assumption. Therefore our assumption is wrong. That means √5 is irrational proved. So 3 marks साठी हा क्वेश्चन डेफिनेटली येतो. 90% क्वेश्चन पेपर मध्ये आहे. So that's why it is very important. We can solve one more question. We can write extra question here. एक्स्ट्रा प्रूव्ह दॅट लास्ट इयर जो विचारला होता क्वेश्चन √3 इज इरॅशनल. शॉर्टमध्ये मी घेतो हा सेम स्टेप्स नो चेंज राईट अप सेम ओनली 5 च्या ऐवजी 3 येणार. √3 is irrational. We can assume that √3 is rational. Here √3 is equals to a upon b. A, b are integers, b not equals to 0. A comma b are co-primes. Cross multiplication √3 into b. Squaring both sides 3b square is equals to a square. 3b square is divisible by 3, therefore a square is also divisible by 3. A is divisible by 3, statement number 1. For now we can write as a is divisible by 3, we can write a is equals to 3 into any integer c. Now put this value here, so it will be 3b square is equals to 3c bracket square. It will be 3b square is equals to 9c square. Dividing by 3 we get b square is equals to 3c square. Now as there is 3 into c square, so 3c square is divisible by 3, therefore b square is also divisible by 3. 3c square divisible by 3, b square is also divisible by 3, so b is divisible by 3. From 1 and 2, 3 is a common factor for a and b, therefore a and b are not co-primes. This contradiction is due to our assumption. Our assumption is wrong, therefore √3 is irrational. This is how we can prove any irrational number. So this is very important question. Now we will go towards question number 2. Now remaining questions in this exercise are for 2 marks. हा इंडिव्हिज्युअली आपल्याला जर समजा √3, √2, √7, √5 इरॅशनल प्रूव्ह करायचे असतील तर त्याला 3 मार्क्स असतात आणि 2 + √5, 3 + √5, 3 upon √5, √3 2 into √3 किंवा 2 into √5 असे जे क्वेश्चन्स आहेत पुढं ऑल क्वेश्चन्स आर फॉर 2 मार्क्स. मग हा नाही विचारला तर त्यावेळेस तो क्वेश्चन विचारला जातो. सो डेफिनेटली आयदर ऑफ द 2 दोन्हीपैकी एक क्वेश्चन नक्कीच विचारला जातो. सो मोर फ्रिक्वेंटली √3, √5 विचारले जातात, परंतु हा क्वेश्चन नंबर 2 अँड क्वेश्चन नंबर 3 हा सुद्धा आपल्याला 2 मार्क्ससाठी विचारला जातो. सो क्वेश्चन नंबर 2, प्रूव्ह दॅट 3 + 2 √5 is irrational. This is very simple question. Prove that 3 + √2 √5 is irrational. See, we know rational plus irrational is irrational, but here we need to prove it is irrational. आता इथं मात्र काय असणार आहे, हा 2 मार्क्सचा क्वेश्चन आहे. आपल्याला √5 हा इरॅशनल आहे हे ऑलरेडी माहिती आहे, त्याचा आधार घेऊन आपल्याला हे प्रूव्ह करायचंय. दिस इज ऑल्सो इनडायरेक्ट प्रूफ. सेम स्टेप. फर्स्ट स्टेप इज लेट अस assume that 3 + 2 √5 is rational. Same. Now as it is rational, we can apply the definition. It can be expressed in terms of a upon b. Therefore 3 + 2 √5 is equals to a upon b, where a comma b are any integers and b not equals to 0. Here there is no requirement for co-prime. Co-prime लिहिण्याची गरज नाही आहे. Only a and b are integers and denominator b should not be 0. Now try to keep root 5 on LHS and other all terms on the RHS. So first transfer 3, so 2 root 5 is equals to A upon B minus 3, that means 3 upon 1. Solve this. 2 root 5 is equals to denominator cross multiplication म्हणूया. B into 1 is B, 1 into A is A, B into 3 is 3B. This is called cross multiplication. Denominator चा multiplication denominator ला, cross multiplication numerator ला. 1 into A is A, B into 3 is 3B, मध्ये minus sign. Now I want only root 5. I don't want 2 also on the LHS. So now transfer this to there. It will be upon. So root 5 is equals to A minus 3B upon 2B. Now look at this RHS. A is integer, B is integer. That's why A minus 3B is integer and 2B is also integer. Integer into 2 is integer and B not equals to 0. That means here integer upon integer and denominator is not 0. That's why this number has to be rational number, because what is the rational number? Integer upon integer and denominator should not be 0, that is rational. Now look at this RHS. A is integer, see, B is integer, that's why A minus 3B is also integer. Look at denominator, 2 into B, B is integer, that's why 2B is integer, and B not equals to 0, that means 2B is not equals to 0. Therefore this has to be rational number. Now जर हा rational आहे, RHS रॅशनल आहे, तर LHS रूट 5 सुद्धा रॅशनल असणारच. परंतु आपल्याला फॅक्ट काय माहिती आता की रूट 5 हा इरॅशनल आहे 100%. नाउ वी गॉट इट. आपल्याला माहिती आहे, वी हॅव लर्न रूट 5 इज irrational, but because of our assumption you are saying that this number, that is RHS is rational, that means RHS also rational. म्हणजे आपण आता म्हणू शकतो की रूट 5 रॅशनल आहे, पण it is contradiction to the fact that root 5 is irrational, and this contradiction is due to our assumption. That's why our assumption is wrong. So we can write very simple statement: A comma B are integers, therefore A and B is not equals to 0. A minus 3B upon 2B is rational. RHS rational आहे म्हणजे LHS सुद्धा rational, therefore root 5 is also rational. But we know it is not rational, it is irrational. So this is again a contradiction. So this is contradiction to the fact that root 5 is irrational. रूट 5 इरेशनल ही फॅक्ट आता माहिती आहे आपल्याला, त्याला कॉन्ट्रडिक्शन मिळालं. आणि मग हे कॉन्ट्रडिक्शन कोणामुळे आहे? दिस कॉन्ट्रडिक्शन is due to our assumption. Therefore our assumption is wrong. What is our assumption? 3 plus 2 root 5 is rational, which is wrong. That's why we can say, therefore 3 plus 2 root 5 is irrational. Proved. So this question is for 2 marks. जर तो नाही विचारला रूट 3 रूट 5 चा, तर अशा प्रकारचा क्वेश्चन विचारला जातो. असेच काही क्वेश्चन 3 मध्ये आहेत. 3 सब क्वेश्चन आहेत. वी विल सॉल्व दीज क्वेश्चन्स within 5 to 10 minutes. last question of this exercise. Question number 3. Prove that the following are irrationals. Question number sub question 1. 1 upon root 2. हा नंबर इरॅशनल आहे हे आपल्याला प्रूव्ह करायचं आहे. सो सेम स्टेप्स, इनडायरेक्ट प्रूफ. लेट अस ॲज्युम that 1 upon root 2 is rational. Therefore we can apply the definition. 1 upon root 2 is equals to a upon b. A comma b are integers, b not equals to 0. Here also co-prime mention करण्याची गरज नाहीये. Cross multiplication, 1 into b is equals to root 2 a. Now transfer this a here. b upon a is equals to root 2. That means root 2 is equals to b upon a. Now see, b is integer, a is integer, b is not equals to 0, but here we need to mention that a, for this step a should not be 0. Then b upon a is rational, and b upon a rational आहे, the root 2 also rational, but this is again contradiction to the fact that root 2 is irrational. Therefore this contradiction is due to our assumption. Therefore we can say root 2 is rational. Very simple. b comma a are integers. Here a should not be 0. Then b upon a is rational. Integer upon integer is rational. मग जर RHS रॅशनल आहे तर LHS ला रूट 2 आहे, तो पण रॅशनल असला पाहिजे. सो रूट 2 इज रॅशनल. आणि मग खालच्या स्टेप सेम लिहून टाकायच्या. दिस इज कॉन्ट्रॅडिक्शन टू द फॅक्ट that root 2 is irrational. This contradiction is due to our assumption. Therefore our assumption is wrong. Therefore 1 upon root 2 is irrational. Proved. So this is also 2 marks question. Now we will solve sub question number 2. What is it? 7 root 5. 7 root 5 is irrational. हे आपल्याला प्रूव्ह करायचं आहे. So same thing, first step, let us assume that 7 root 5 is rational. Therefore we can write 7 root 5 is equals to a upon b, where a and b are integers and b not equals to 0. So root 5 is equals to, transfer this 7 there, a upon 7b. Now here we can write a is integer, b is integer, a comma b are integers, and b not equals to 0. Therefore, RHS has to be rational. That means root 5 is also rational. But fact is that root 5 is irrational. We know that. So again, this is contradiction to the fact that the root 5 is irrational. And this contradiction is due to our assumption. That's why our assumption is wrong. And I can write 7 root 5 is irrational. So a and b are integers, b not equals to 0. Therefore, a upon 7b is rational. Therefore, root 5 is rational. This is इथं आहेच ऑलरेडी लिहिलेलं तेच लिहा. दिस कॉन्ट्रडिक्शन इज दिस कॉन्ट्रडिक्ट्स पाहिजे, दिस कॉन्ट्रडिक्शन नको, दिस कॉन्ट्रडिक्ट्स टू द फॅक्ट दॅट रूट 5 is irrational. This contradiction is due to our assumption. Therefore, our assumption is wrong. Therefore, we can write 7 root 5 is irrational proved. So, this is question number 2, sub question 2. Now, last is third मध्ये आणखीन एक क्वेश्चन आहे, सब क्वेश्चन 3. 6 plus root 2. Same step. Let us assume that 6 plus root 2 is rational. Again, there is no need to write co-primes, only integers, and b not equals to 0. 6 plus root 2 is equals to a upon b. Root 2 एका बाजूला ठेवा. This will be a upon b minus 6. Solve this. So this means 6 upon 1, which is equals to denominator b cross multiplication a minus 6b. As a is integer, b is integer, a minus 6b is also integer. B is integer and b not equals to 0. Therefore, a minus 6b upon b, that is integer upon integer, and denominator is not 0. Therefore, RHS is rational. That means LHS is also rational, that is root 2 is rational. But we know the fact is that root 2 is irrational. This contradiction is due to our assumption. Therefore, our assumption is wrong. Therefore, we can write 6 plus root 2 is irrational. So, a comma b are integers, b not equals to 0. Therefore, a minus 6b upon b is rational. Therefore, root 2 is rational. This contradicts to the fact that root 2 is irrational. And the next statement is same. This contradiction is due to our assumption. Therefore, our assumption is wrong. Therefore, 7 root 5 is irrational proved. Here ends the exercise 1.2. In the next period, we will start lesson number 2, polynomials. Thanks.